Hello, everyone. In this lesson, I wish to go over some questions that to find a function from its derivatives. Examples such as, we are given the first order derivative or second order derivative, and then we're going to find f. So it's basically layers of antiderivative that we're going to find. For example, here, number 7, we have a third order derivative given, and then we want to find the function itself, okay? Before we start, if we, I try to fit this in not too long, maybe not exceeding too much of an hour. Otherwise, we'll make another video. In case we need the formula as our reference, I'm going to do a little reorganizing of these formula. Okay, for example, this column here, I can make it a bit narrower. Okay, I'm going to call it antiderivative, right? We'll make it a little shorter, and the next one we also make it antiderivative. Make this one a little bit shorter, and we're going to bring these. Okay, we're going to bring these to let me, so I can copy and paste all of these right underneath the questions that we're going to work on, okay, in case we need to, we need a reference to them. And I hope that you guys also have your paper pencil ready and your index card with these formula. Okay, so let's get started. So here's the formula here. Okay, just in case we need, I assume that after a while you don't need it as much. But just as some example, these kind of questions, sometimes in differential equation course is called solving differential equation, okay? But here we don't call it solving differential equation, is that we just want to, from the first order derivative that's given, we want to find the function itself, okay? And we are also given some additional conditions, okay? And with these additional conditions, you will find out that we are going to use these conditions to determine one or two the constants that are given. Okay, each condition determine one constant. Two conditions determine two constants. So before further ado, without further ado, let's get started, okay? We have the first order derivative and we just going to, so from first order derivative, we're going to find f, right? And of course, we know all of these properties, we only have addition subtraction. So over here, we know the antiderivative of e to the power x, and we also know that 1 plus x squared parentheses raised to the power -1 is equals to 1 over 1 plus x squared. So now we pretty much know what is the antiderivative, which is arctangent. All right, so f, okay, so f of x, f of x is the antiderivative of f prime, okay? Function f is the antiderivative of its first order derivative. The antiderivative e to the power x is e to the power x, okay? And plus 20 multiply arctangent of x. And don't forget the constant, okay? We add a constant. So we found the antiderivative, the most general form, okay? And next we're going to apply we're going to apply this condition this condition basically says we're going to plug in, right? We're going to plug in x equals to 0, right? So x will be replaced by 0, x replaced by 0, x replaced by 0, and it equals to negative 2. So from this relationship, we are to find the value of c, okay? E to the power 0 equals to 1 plus 20 multiply arctangent of 0 is 0. So plus constant c equals to negative 2. So we're solving for c, and c would be equal to subtracting 1 from both sides, negative 3. So finally, right, finally, the function we are looking for that satisfy its derivative equals to the given form, and also the function's value at 0 equals negative 2 satisfy both conditions. Okay, sometimes we call the latter initial condition. Okay, initial condition. C is negative 3, so we can just write minus 3. And that's it. That's finished. That's finished. Okay. Now let's look at example number 2. Example number 2, we are given 2 conditions. We're given 2 initial conditions. Okay. So once again, it's pretty much the same drill. Okay, except this time we are going to generate 2 constants. All right. Let me just quickly double check. Yeah, it should be. All right. So this time we need to do antiderivative twice. Okay. The first one is we get f prime. F prime is the antiderivative of f double prime. Okay. So let me write it down. Is an antiderivative of f double prime. Okay. And f is an antiderivative of f prime. Oops, sorry. F prime. Okay, so that's the relationship. As you probably, I'm sure you do understand, but I just want to make sure everybody is on the same page. All right, so first we're going to find f prime from f double prime. So f prime is the antiderivative of f double prime. So we're going to find the antiderivative of these, which is equal to 12. Okay, the antiderivative of x squared is x raised to the power 3 divided by 3, okay, which is this one, okay, plus 6x. The antiderivative of x is half x squared. Okay, minus 4. 4 is a constant, so it's a 4 multiply x. And then we're going to plus a constant. Since we have 2 initial conditions, typically we may have 2 constants. So I'm going to name this one constant number 1. Okay, and simplify. You could well simplify over here. Okay, but I just want to write an extra step so everybody can see what's going on, right? So now we got 4 times x raised to the power 3. Okay, and 6 times half, that's 3. and we got the antiderivative of f double prime. And then from f double prime, you can see from double prime we get f prime, and now from f prime we're going to get f of x. So f of x is the antiderivative of f prime. Okay, so we're going to find antiderivative for each one of these. So now, including the constant c1. Okay, so 4 times antiderivative x raised to power 3 is, if we follow the power rule formula, is 3 plus 1, that's x raised to power 4, right? So this is basically it's 4, right? So now you can already simplify this already, okay? Plus 3 times the antiderivative of x squared. Okay, we just had it, so how about we just copy and paste right there. And that will make another one, we simplify, minus 4 times x, the antiderivative of x is half of x squared. So this will make 2 plus c1 multiply x, right? C1 is a constant, its antiderivative is multiplied by x. Plus, now we have another constant, C2. So finally, we get to this point. And then we're going to apply these 2 initial conditions. We're going to apply 2 initial conditions. Okay, so we're going to apply these 2 conditions. Okay. Apply the first condition, f of 0. So this is 0. Every x is replaced by 0, right? And this is replaced by 0. And f of 0 equals to 4. So from this equation, you can see we get a bunch of zeros. So this will lead us to c sub 2 equals to 4. Okay. Now we're going to apply the second condition. Okay, f sub 1. I'm sorry, not f sub 1, f of 1. F of 1. But by this time, C2 is already known, which is 4. Right? So we're going to substitute x by 1, by 1, by 1, and x by 1. Okay? F of 1 equals to 1. All right? So we're solving for C1. That makes 2. This is a minus 2. So this will be 0. This piece will be 0. So we get C1 plus 4 equals to 1. So C1 plus 4 equals to 1. C1 times 1, of course, that's C1. So finally, C1 would equal to -3. So finally, our final answer, the F, would be the result of substituting C1 by its equal, C2 by its equal, which equals to 4. And that's finished. Okay, so you can see that's the general steps of finding antiderivatives with additional conditions. So we can determine constant 1 and constant 2, maybe constant 3, according to the additional given conditions. They are usually called initial conditions. All right. Number 3. Okay, example number 3. Example number 3, we were not given any additional condition. We're not given any additional condition, that's fine. We can still find f prime and the f. Okay, so it's still the same relationship, so we're not going to repeat this time, right? F prime is antiderivative of F double prime. F is an antiderivative of F prime. So we can just go ahead to find F prime equals to, right, the antiderivative of 24x, right? And the antiderivative of x is half x squared. Okay, plus constant number 1. And this, of course, is 12. And there you're done. F double prime, I'm sorry, F. Okay, so antiderivative one more time, because we're doing this layer by layer. So 12 times the antiderivative x squared is third times x raised to the power 3 plus c1 times x plus a c2. Okay, so that piece makes 4. So that's the final answer. That's the final answer. We have no additional conditions. So C1, C2 are arbitrary constant. So you can see the solution to F is not unique. The solution to F prime is not unique either. So we have like a family of functions that to be qualified for F prime, given F double prime is 24x. And we have families of solution to F. Okay, so lots of solutions, lots of solutions. Now let's look at number 4. Okay, example number 4. The same drill, pretty much the same drill. You can pause if you like to find your own. Okay, so we got 4 times x raised to the power 3 is antiderivative. It's 1 over 4 x raised to the power 4 and plus 24x, right? The antiderivative of x is half x squared minus x plus c1. Simplify, this is going to be 1 and this is going to be 12. And that's F prime. F of x will be the antiderivative of the first order derivative. So this piece will be 1 over 5 x raised to the power 5 plus 12 multiply the antiderivative of x squared is third of x raised to the power 3 minus x. The antiderivative of x is half of x squared. You can see you're getting used to it. Okay, half of x squared plus c1 times x plus c sub 2. Okay, so simplify, this will be 4, and that's the answer to F. Once again, there are many possibilities. There are many possibilities. Number 5. Okay, number 5. So far, we've been doing a lot of powers. So what will be the, for this case, right? We are given an additional condition, which is x is greater than 0. Okay. All right, so keep that in mind. So we first get F prime. F prime, the antiderivative 1 over x squared is negative 1 over x plus constant number 1. Okay, and F would be negative ln x plus c sub 1 of x plus c sub 2. Finished. No addition conditions. And then you say, where did we apply that x greater than 0? Well, we apply that by choosing this formula for the antiderivative of 1 over x. Okay. Now let's look at example number 6. Okay, example number 6. We got exponential function. We got exponential function. So once again, we got f prime of x equals to the antiderivative of 2x, right? Is x squared. Is x squared. So that's x squared plus 3 times e to the power x. Antiderivative e to the power x is the same, plus c sub, plus c sub 1 and f of x equals to the antiderivative x squared, which is a third of x raised to the power 3 plus 3 times e to the power x, right? So this part is the same, plus c sub 1 of x plus c sub 2. Done. Finished. Once again, many solutions. So let's get over 7 and 8. Okay, these are related to trig functions, so we get to apply those trig function antiderivatives. All right, number 7, but this time look, we got triple derivative, right? So we got triple derivative. So we're gonna start with third order derivative. So the antiderivative of third order derivative is second order derivative. So we get f double prime of x equals to, the antiderivative 12 is 12x. The antiderivative of sine x was antiderivative sine x. Was antiderivative sine x. Do we still remember? Then has a negative cosine. Yes, negative cosine. Okay, so if you combine the, plus and minus, that's what we got. Plus constant C1. And then we're going to find first order derivative equals to, right? So 12 times the antiderivative of x, which is 12, but which is half x squared, minus what's the antiderivative of cosine x? That's sine x. And what's antiderivative C1? C sub 1 times x, then we plus C2. Okay, last, okay, we simplify this, we get 6. We're almost there. So f of x, which is the antiderivative of f prime, and that will be 6x squared, the antiderivative 6x squared. The antiderivative of x squared is third x raised to the power 3. So we got a 6 in front of it. So that's going to be a 2. And the antiderivative of sine x, the antiderivative sine x is negative cosine x. So over here, we're going to have a negative cosine x. Of course, that's going to be plus cosine x plus the antiderivative of C1 times x. We're going to write C sub 1. Wait. C sub 1. Let me continue to be consistent, right? So that's going to be x squared over 2. The antiderivative of C sub 2 is C sub 2 times x. So now we have to add a C sub 3. Okay, almost done. So finally, okay? And this will be minus, minus, this is gonna be plus. So this is gonna be plus. And here C2 over 2, we can write C2 over 2. So this is just x squared. Okay. Can we call this whole thing C1? Yes, we could. We could. Then you think, how could C1 be equals to half of C1? Okay, because C1 is arbitrary. Because C1 is arbitrary. Divided by 2 is still arbitrary. Okay, so, but if your answer is this, no problem, it is correct. Okay, but if you say, okay, I'm going to write the answer as I'm just going to call this whole thing C1 again. That's not a problem either. So both are correct. Both are correct. Okay, let's look at the example number 8. All right, so let's look at number 8. Okay. We got power with fraction power. Okay. So we're gonna do layer by layer. Okay, so first double prime, f double prime is the antiderivative of f triple prime. The antiderivative of root c, okay, you can use, we've done this before, right? So now we got to do t. Okay, we got to do the t. And you think of root t as t to the power of half. So over here, you're gonna have half plus 1 and t raised to the power of half plus 1 is 3 half. So this is going to be 3 half minus 2. The antiderivative of cosine is sine. All right. So over here, that's going to be 3 half. And 1 over 3 half is 2/3. All right. And plus a constant number 1. By this time, you probably have seen a pattern, right? If we have the first order derivative, then we will just have one constant. Okay, we just have one constant. If we have second order derivative, then we have two constants. Three order derivative, we will have three constants. Okay, so that's the pattern. Then we're gonna find, can we simplify? No, this is not simplifiable. So f prime of t, f prime t is the antiderivative of double prime. So we're gonna find the antiderivative of, this will be 2/3, right? And we work with the antiderivative of t to the power of 3 half. So that's going to be 1 over 3 half plus 1 t raised to the power of 3 half plus 1. All right, and that's going to be 5 half because 1 equals 2 over 2. So that's going to be 5 half. Right, so this is going to be 5 half. 1 over 5 half is 2 over 5 minus 2 times this antiderivative sign is negative cosine. So this is going to be negative cosine t plus c sub 1 of t multiply c2. All right, so here is minus 2 times negative cosine t. So negative will make positive. All right. And finally, f. Finally, f. F of t is equal to well, we could have simplified here. And if you don't simplify, it's all right. Okay, we just keep these two constants. Okay, we can multiply now, which is 4 over 15. Right, 4 over 15. And the antiderivative of t raised to the power 2/5. And this time is going to be 1 over 2/5 plus 1. Plus 1. And t raised to the power of 2/5 plus 1. Okay. Antiderivative of cosine is sine. So plus. Oh, did I miss a 2 here? Yeah, I missed a 2 here. So this is going to be 2 times sine of t. Okay, and plus c1. The antiderivative of t is half of b squared. Half of b squared. That's c1t plus c2 of t and plus c sub 3. 3 constants. Okay, 3 constants. So by this time, we just have to organize our terms. Keep that step. Okay, so I'm gonna organize this term, organize the term in the next one. So this is gonna be 7 over 2. And this is, of course, is 7 over 2. And 2 over 7, right? And simplify, no common factor. So this is gonna be 8. 15 times 5. 15 times 5, I think it's 15 times 5. 57, 35. 1 times 7 is 105. All right. So that's 15. Wait. This was 7, right? So 15. Let me just double check. Okay, 15 times 7. My mind is not working. 105. Okay, we're right. Okay. 2 times sine t, c1 times c times half. So this is c sub 1. And wait, so this could be gone. Okay. And we're done. We're done. Number 8. So you can see we start to see a variety of functions. Okay. Next, we're going to see these examples with initial condition or additional conditions. Okay. So let's get started. Let's get started. Number 9. Okay, number 9. Number 9. All right. We are given first order derivative. We are also told x is greater than 0. Okay, so we can have f of x. So that will be the antiderivative first order derivative, right? So we got 8 multiply x raised to power 3. That antiderivative is 1 over 4 x raised to power of 4 plus ln x plus constant. Okay, we only have one constant, so there's no need to introduce subscripts. So now this is just 2. And then we're going to apply the condition f of 1 equals to 3, right? So the function we got we're gonna substitute x by 1. Okay, and that's going to be -3. We're solving for c. And that part is 2, that ln1 is 0, so 2 plus c equals to -3. Finally, c would equals to -5. Okay, and our final answer for f, would be -5 replaced with c. That's it. Okay, so let's continue. Let's continue on number 10. Number 10 actually is pretty straightforward. I think I'm going to skip some. I'm gonna skip some of these examples. Okay, I think you guys can handle it. These are mostly homework questions, and here they are. If you want, you can pause and do it right now. I'm going to get to number 14. Okay, I'm getting to number 14. Number 14, you understand why I choose it, okay? Because we do need a little more manipulation here because we know there's no quotient rule nor product rule in finding antiderivative. So we have to, before we find the antiderivative of f prime, we need to simplify. Okay, we're going to turn this into product. No, turn into adding or subtracting. So which means that we're going to have x divided by root x. Okay, and then plus 1 over root x. And after this simplification, right, so we get a root x over here and plus 1 over root x. Now we can find the antiderivative. And of course, you can express it in power form. Okay. If you are to express it in power form, then you know that's probably a bit easier for everyone. But you can just go for it, okay? And you can just go straight to it. Okay. So this is gonna be f, which is the antiderivative of f prime. And here, we've done this many times over. So by this time, I think it's going to be pretty easy for everyone. Let's just finish it, okay, since we decided to do it anyway. So this is going to be x raised to the power of 3/2 plus. And this one is 1 over root x. So it's x raised to the power -1/2. So all of these, okay, is -1/2 plus 1, and this is x raised to the power of 1/2. And don't forget the constant. Okay, we just have one constant here. Simplify. Okay, so this is 3/2. 1 over 3/2 is 3 under 2. And this is going to be 2. And then we're going to plug in this number. We're going to plug in this number, f of 1 equals to 5. And f of x, oops, is right here, right? And plug in f of x by x equals to 1. So this is 1, and this is 1, and that should equal to 5. We're gonna solve for C. Okay, so we get 2/3. Okay, 2/3 plus 2 plus C equals to 5. So finally, C equals to 3 minus 2/3. Okay, and 3 is 9/3. 9/3 minus 2/3, that's 7/3. Okay, so that was number 14. We skipped several. And for the rest of them, some of these have a derivative as the initial conditions. So we're gonna do a couple more. Okay, once again, we're gonna select because we're not gonna make this too long. So let's see, what are we gonna choose? I think for the following questions, I will just select 2 more. One is 18, which involves trig function. And then I will choose number 20, 18 and 20. Okay, and then we're gonna end this recording. All right, so number 18 and number 20. Okay, the reason is that we got trig functions and exponential functions in these 2 questions. And they also have 2 initial values. Okay, let's look at number 18. Okay, the antiderivative of second order derivative would be the first order derivative of the function f. And the antiderivative of sine theta is negative cosine theta. And the antiderivative of cosine theta is sine theta. Sine theta. And then we need to plus a constant C sub 1. Okay. At this point, we can substitute, we can apply this initial condition. Okay. And then we will replace theta by 0. Okay. So all the theta will be replaced by 0 and it equals to 4. And negative cosine 0. Okay, so we got this equation here, and cosine 0 is 1, so this negative 1. Sine 0 is 0. So we got negative 1 plus C1 equals to 4. And in the end, C1, C sub 1 equals to 5. So by this time, we got the first order derivative would be 5. This function negative cosine theta plus sine theta plus 5. Okay, and then we're going to do one more step, which is find f. Okay, so the antiderivative of the first order derivative is the function itself, and that equals to negative the antiderivative of cosine theta is sine theta. And the antiderivative of sine theta is a negative cosine theta. Negative cosine theta. So we can just write a negative plus 5 times theta plus another C sub 2. Okay, plus C sub 2. And now we're gonna apply the other condition. okay? So theta equals to 0 again, 0, 0, 0, and that equals to 3. Sine 0 equals 0, so this piece is 0, and negative cosine 0, that's going to be negative 1. 5 times 0 is 0, plus c sub 2 equals to 3. So in the end, c sub 2 is equals to 4. All right. So finally, the function would be, okay, c2 will be replaced by 4. And that's the final function, which satisfies the 2 additional conditions. And last but not least, for this recorded lesson, okay, number 20. This one involves exponential function and trig function, right? We have 2 conditions, but these 2 conditions, they're about function. It's not about, none of them is about the first order derivative, okay? So here we go. First we get f prime, say x, right? That will be equals to the antiderivative e to the power x is e to the power x minus 2 times the antiderivative sign is negative cosine. So negative cosine x. And plus the constant sub 1. Okay. And over here, negative, so that's going to be just a positive 2 times cosine. All right. So we're going to keep the C1, and then one more step. The function, which is the antiderivative of its first order derivative, the antiderivative e to the power x is e to the power x, plus 2 times the antiderivative cosine is sine, plus c sub 1 times x plus c sub 2. Okay, now we're going to apply these 2 conditions. First one, second one, right? On the first one, substitute x by 0, 0, 0, all the x replaced by 0 and equals to 3. Second one, we're going to substitute everything by pi over 2. Everything x is replaced by pi over 2. Pi over 2. Multiply pi over 2. That equals to 0. So we ended up with 2 equations. Okay, we ended up with 2 equations. From the first equation, that's equal to 0, right? C1 is times 0 is 0. E to the power 0 is 1. So C2, C sub 2 equals to 2. Okay, and the second equation, it looks a little bit more complex. Sine pi over 2 is equals to 1. Okay, not 2. So this whole thing is 2, and C2 is 2, right? C2 is 2. So 2 plus 2, 2 plus 2 is 4. All right, and then we're solving for C1. So we will keep this pi over 2 times C1 on the left-hand side. We can bring pi over 2 to the front of C1. Okay, and that equals to -4, right? We subtract 4 and subtract e to the power of pi over 2. And then we're going to multiply. Okay, we're going to multiply on both sides the reciprocal. Okay, the reciprocal of pi over 2, which is 2 over pi. Okay, we multiply 2 over pi on both sides. Multiply, right? Multiply. Okay, so this way C1 will be isolated. C sub 1 is isolated, and that's going to be negative 8 over pi, 8 over pi, minus pi, 2 over pi, oops, 8 over pi, minus 2 over pi times e to the power pi over 2. So that's C1. Okay, so going back to this equation, to the function, and finally F C1 will be going here. Okay, so C1 will be going here. C2 will be 2. And that's it. And of course, if you want to pull out the negative sign, and you can put it outside. So this inside would just be plus. Okay, I think that's the end of it. I don't think these questions will be super difficult for you, so I'm not going to go over all of them. If you have any questions, and here, well, they're all from your homework, so you can ask me. So I'll be happy to answer your questions. But for now, I think this lesson should not be too long. Thank you for watching.